Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at how to solve systems of linear equations by graphing. Don't forget, we have some practice problems at the end of this presentation for you to try out in order for you to demonstrate mastery of the contents of this tutorial. So be sure to watch the entire thing and try out those practice problems. Alright, so the instructions for the examples that we're working on are for us to solve the systems of equations by graphing. So let's say we have the following system for number 1, y equals 4/3 x plus 3, and y equals negative 2/3 x minus 3. Okay, so what we're going to do is we're going to go ahead and graph these two lines, and remember that the intersection represents the solution. All right, so whenever you're solving systems of equations by graphing, you can either have no solution, which means no intersection, one solution, which means one intersection, or infinitely many solutions, which means you have two overlapping lines that intersect infinitely. Okay. All right, so let's label these lines. Let's see, this is 1 and 2. So the two lines are in slope-intercept form. So it's easy for us to graph them by just using the slope and the y-intercepts. So let's start with equation 1. So from equation 1, we have y equals 4/3 x plus 3. So the slope-intercept form of the equation of a line is y equals mx plus b. So that tells us that m is 4/3 and b is 3. Okay, so that's all the information we need to graph a line. We just need the starting point, the y-intercept, and the slope to take us to another point, because 2 points define a line, a minimum of 2 points. All right, so let's do it. So our slope, now let's start with the y-intercept. So the y-intercept is b, and that's going to be 3. All right, so since the y-intercept is 3, that basically tells us that we're going to begin at 0, 3. So begin at the y-intercept 0, 3. Okay, and then our slope, which is m, is 4/3. So it tells us the movements to the second point. So you're going to move 4 units up, rise, overrun, and then 3 units to the right. So that's for the first equation. All right, so for the second equation, equation 2, what do we have for that one? So for equation 2, let's do this. Let's go ahead and graph equation 1 first, and then we're going to graph the second system right on top of it. Okay. All right, so let's set up our coordinate system right here. So there goes our y-axis and our x-axis. All right, so let's label the axis here. Our x-axis is the horizontal line, and then the y-axis. Okay, so we're going to start with the y-intercept, begin at 0, 3. So 1, 2, 3, 0, 3. And then you're going to rise 4 and run 3. Okay, so if you notice, if we rise 4 and run 3, we're going to go off our coordinate system. So rising 4 and running 3 is the same thing as going down 4. 1, 2, 3, 4, and backing up 3. 1, 2, 3, right there. All right, so this is another point that falls on the line. So anytime you're graphing using the slope-intercept form and your point ends up outside the graph, you can just reverse the direction of the slope in order to get a point on your coordinate system. Okay, so we can even do another one. Go down 4, 1, 2, 3, 4, and then back up 1, 2, 3. You notice if you start from this point, is equivalent to going up 4 and over 3, right? All right, so you see how the points line up. The points line up perfectly. Okay, so let's go ahead and draw our line for equation 1. There it is right there. Bam, that's the line for equation 1. Now, what we're going to do next is we're going to graph the second line. All right, let's make sure it's perfect right through the points. Okay, all right, let's draw this graph the second line. So for the second line, we need to follow the same procedure that we used for the first one. For equation 2, what do we have? So for equation 2, let's do it in green. For equation 2, we have, it's also in slope-intercept form, which is convenient. Y equals negative 2/3 x minus 3. Okay, so for this one, the y-intercept, which is b, is negative 3. What does that mean? We're going to begin at 0, negative 3. That's the first point. And then your slope, m, is the coefficient of x is negative 2/3. So that tells you your moves, right? So you're going to move 2 units down because the rise is negative, and you're going to run 3 units. You always run with the slope, okay? You can rise or fall, but you always run. All right, let's go ahead and graph that. So you'll begin at 0, negative 3, sorry. So y-intercept is negative 3. So begin at 0, negative 3. 1, 0, 1, 2, 3. So there goes your y-intercept for equation 2. So you drop 2, 1, 2, and you run 3. 1, 2, 3. Okay, there goes the next point. Or you can go up 2, 1, 2, and back up 1, 2, bullseye. Excellent. See how they overlap perfectly here? That's great. So let's go ahead and draw the line for the second equation. Okay, so it's going to look something like this. So what is the solution to the system? The solution to the system is a point that lies on both lines. All right, that's the solution to the system. The point of intersection is your solution. So the point of intersection is right here, bam, bam. The x-coordinate is negative 3, and the y-coordinate is negative 1. So that point right there is your solution. So let's write it here, our solution. There are two ways you can write down the solution. You can write it as a coordinate. You can write it as negative 3, negative 1, or you can write it just by specifying that x is equal to negative 3 and y is equal to negative 1. All right? So that's basically how you solve systems of equations by graphing when both lines are presented in slope-intercept form. All right, let's take a look at question 2. Let's say we have y is equal to 1/2 x minus 1, and y is equal to 1/2 x plus 4. All right, so when you take a look at this system, you notice something similar between the two lines, which is that they both have the same slope, but their y-intercepts are different. So anytime you have a situation like this with the same slopes and different y-intercepts, you're going to have parallel lines that never intersect. So if they never intersect, that means that there's going to be no solutions. All right, so let's take a look at what that looks like graphically. Let's label the lines again. That's equation 1 and equation 2. Okay, so let's start with equation 1. Let's make equation 1 blue. So equation 1, we have the equation y is equal to 1/2 x minus 1. So with this particular one, our y-intercept b is negative 1, right? So we're going to begin at the point 0, negative 1. And then our slope, what's the slope? The slope is the m value. Do that again. Slope m is the coefficient of x, which is 1/2. So that tells us our move. We're going to move 1 unit up, rise 1, run 2, because slope is rise over run. All right, let's go ahead and graph that. So we have our coordinate system. Let's label our coordinate system. This is the y-axis, and this is your x-axis. So for the first one, you're going to begin at 0, -1. So that goes your first point. And then you're going to rise 1, run 2, 1, 2. Rise 1, run 2. Rise 1, run 2. Okay, or fall 1 back up 2. Fall 1 back up 2. Fall 1 back up 2. I want to occupy my entire grid with the points. What's going to happen is that there are not going to be any intersections. So I just want to make you see that that's the case. All right, so let's draw a line that defines equation 1 right there. Let's adjust it slightly. So, all right, there you have it. Okay, so let's go ahead and draw this equation 2. So this is the first one, equation 1. The second one, we're going to follow the same steps to generate that graph. Okay, so for the second one, equation 2, we have y equals 1/2 x plus 4. So in this case, the y-intercept b is 4. So that means we're going to begin at 0, 4. And your slope m is 1 over 2. So your move is going to be the same as the first one. You're going to move 1 unit up and 2 units to the right. All right, let's go ahead and graph that. So y-intercept is 4. 1, 2, 3, 4. 0, 4 is where you start. You're going to rise 1, run 2. Rise 1, run 2. Or you can fall 1 back up 2. Fall 1 back up 2. Fall 1 back up 2. You can clearly see here that the lines will never intersect. All right? They are two parallel lines. Parallel lines never intersect. So since they never intersect, what is the solution? The solution is a point of intersection. So since they never intersect, that means that there are going to be no solutions. Okay, so there you have it. Let's go ahead and write down our answer. We have equation 2 graphed. So there are no solutions since the lines are what? The lines are parallel. All right, let's take a look at another example. What if the lines are presented in standard form? So for number 3, let's say we have the following system. So for number 3, we have 3x minus 2y equals -2, and x plus y equals -4. Okay, so let's take a look at how to solve this system by graphing. Okay, so let's label them equation 1 and 2. So this is equation 1, and this is equation 2. Let's start with equation 1 first. So from equation 1, we have 3x minus 2y equals -2. Now you can graph this using intercepts. Just set one to 0, find one intercept and then the other. I'm going to solve this using, graph this using the slope-intercept form. So to put in slope-intercept form, we're simply just going to solve for y, and then we should be good to go. All right, so let's specify this is known as a standard form, and we want to change it into slope-intercept form. So we solve for y. Okay, so to solve for y, we're going to subtract 3x from both sides. We're solving for y because that's the slope-intercept form. Okay, subtract 3x from both sides. That will give us negative 2y is equal to negative 3x minus 2. And then divide everything by negative 2. Negative 2, negative 2, negative 2. And then you have y is equal to 3 over 2x plus 1. Okay. So now we can find the components to graph. Our y-intercept, which is our starting point, y-intercept b is equal to 1. So that means we're going to begin at 0, 1. And then our slope, m, is equal to 3 over 2, which tells us our move. We're going to move 3 units up and 2 units to the right, starting from 0, 1. All right, so let's go ahead and graph that. Okay, so our y-intercept for equation 1 is 1, 0, 1. All right, so we're going to rise 3, 1, 2, 3, and run 1, 2. Okay, or we can fall 1, 2, 3, and back up 1, 2. Fall 1, 2, 3, and back up 1, 2. And there you have it. Those are the lines, the points that define the line for the first equation. So let's make that blue and graph it. All right, so there goes your first one. Now we're going to go ahead and graph equation 2. We're going to follow the same procedure of converting it into slope-intercept form. Remember, you can also graph it using intercepts, but it's more consistent and easier when you do it using the slope-intercept form. Okay? All right. So for the second one, what if we have, well, we have x plus y equals 4. So for equation 2, we have x plus y equals negative 4. This is the standard form. All right, I forgot to state something in the previous one. This form that we have here is a slope-intercept form because it tells you the slope and the y-intercept. All right, so to get this in the slope-intercept form, just get y by itself. That's all you do. So for this one, you just subtract x from both sides. Solve for y will result in the slope-intercept form. So we're going to have y equals negative x minus 4. Okay, so for this one, so this is the slope-intercept form already. So for this one, our y-intercept, which is where we're going to begin from, our y-intercept b is negative 4. So we're going to begin at 0, negative 4. And then our slope m is negative 1. All right. So our move, we're going to have to write it as a fraction, right? It's going to be 1 unit down and 1 unit over. So think about a slope. If a slope is an integer, just put the 1 underneath to specify what your run is. If it's an integer, your run is always going to be 1. Okay, now let's graph it on the same coordinate system. Our y-intercept or beginning point is 0, negative 4. 1, 2, 3, 4. So here is our slope. So the directions is we're going to go down 1 over 1. Takes us there. Or we can go up 1, back 1. Up 1, back 1. Ooh, jackpot. Up 1, back 1. There goes the point that defines the second line. So let's go ahead and graph the second line. Make it green. Bam. There you have it. So you see where they intersect. The point of intersection represents the solution to the system. So there you go. See that point right there, that point of intersection? That is the solution to the system of equations. All right, so let's write it down. Our solution is the coordinate point -1 on the x and -2 on the y. So -2 on the x and -2 on the y, so it's -2, -2. Or you can write it as x equals -2 and y equals -2. Okay, so that is how you solve systems of equations by graphing.